Hello, today we continue to learn how to work with redox reactions. We will equalize such chemical equations using the electronic balance method, which uses the degree of oxidation. So in the previous lesson, we found out what stages this equalization procedure consists of. It includes several stages that we must perform in order to select the coefficients in this chemical equation. Only I chose a more complex example for today's lesson. So this is the interaction of potassium permanganate with hydrochloric acid. This is a very interesting reaction that serves in a chemical laboratory for the production of chlorine. It is considered its laboratory method of production. This reaction is carried out in a special cabinet since chlorine is a very poisonous reptile, and so that the laboratory assistant does not suffer from such a chemical reaction, it must be done using special equipment. So, what is the reaction between potassium permanganate, potassium manganese O4, and hydrochloric acid? During this reaction, potassium chloride, manganese chloride, chlorine, and water are released. So let's start with the first stage. We had to write an incomparable reaction scheme. Here it is just written down and put down the degree of oxidation of each chemical element. We are starting to work with potassium manganese O4. Recall that at the end there is an element with the lowest degree of oxidation, or it is the most electronegative. This is of course oxygen. Then we switch to potassium. Potassium will have a +1. We calculate manganese through the equation. +1 plus x minus 8 is 0. This means that manganese will have a +7. Now we start with chlorine. -1 hydrogen then has +1. Into potassium chlorine, chlorine has -1, potassium has +1. Into manganese chlorine 2, chlorine has -1, manganese has +2. Chlorine 2 with 0 charge, since it's a simple substance. Well, water has -2 and hydrogen +1, using the rules of the cross. So which elements have changed their oxidation state? Well, it's obviously manganese, and the second element is chlorine. And drawing your attention only that one has changed to a 0 charge, because here and here in these formulas the charge has not changed for chlorine. Now we write down two half reactions. The first half reaction goes for manganese. Manganese from +7 goes to manganese +2. The degree of oxidation for it goes down, which means that manganese must, it turns out, accept 5 electrons. When the oxidation degree goes down, the element must accept electrons. It will be an oxidizer. Now next, the second element is chlorine. Chlorine goes from -1 to 0 chlorine, but because the chlorine molecule has an index 2, we have to take this 2 into account. Add chlorine goes to increase, and hence in this connection it must give up 2 electrons. But it is customary to write it down in such a way that on the right side we get +2 electrons, and if we wrote down on the left, the sign would change. Now comes the purely technical work. We take the numbers 5 and 2 that we found, swap them crosswise to balance them out. The first process is called reduction. And the element manganese itself will be called the oxidizer. So the second process is oxidation. And this element will function as the reducing element in the process. Now we have to put the basic coefficients 2 and 5 into our not yet equated interaction. So the 2 will go according to the rules of arrangement. It should be put where manganese has the lowest oxidation degree, where it's +2. So our 2 goes here. 5. 5 we should put at chlorine with 0 charge. According to the rules of arrangement, it is necessary to put in the first place to the zero charge. If it is not, then to the smallest. Then 5 we will put in front of chlorine 2. Now further we begin to equalize by placing auxiliary coefficients. Manganese on the left is 1, on the right is 2. We put 2 in front of the potassium formula for manganese 4. On the left side, potassium is 2. Here it's 1. So we put a 2 in front of potassium chlorine. Now chlorine, because it's 1, but let's count it. First we have 2 and then we add another 4 to make 6. Adding 10 more gives us 16. Now let's add 16 chlorine atoms. Moving on to hydrogen, we have 16 atoms on the left side and 2 on the right side. To balance the equation, let's add 8 water molecules containing 16 hydrogen atoms. Now onto oxygen, we need to add 2 times 4, which gives us 8 oxygen atoms on the left side. On the right side, we also have 8 oxygen atoms. This results in the following equation. However, it's important to note that in such equations, signifying the state of each substance is necessary to indicate the interaction between substances. In this case, we can consider potassium permanganate as a solid. Hydrochloric acid is a solution. Potassium chloride would then be taken as a solution. Manganese chloride would also possess similar properties. In this particular situation, the gaseous element present will be chlorine, while water will exist in its liquid state. Thus, we have successfully demonstrated that this reaction occurs under specific conditions, allowing us to evaluate the aggregate states involved. Additionally, certain equations may require the inclusion of an ionic equation as a result. In this case, we can construct such an equation by incorporating ions and arranging them accordingly if needed. Similarly, we can perform this process for the given chemical reaction. For instance, it could take the following form: 2 potassium ions plus 2 manganese O minus, plus a further 16H plus. That's in solution, plus 16 chlorine minus. That's in solution, equals 2 potassium. Plus in solution, plus 2 chlorine minus in solution. Plus you get 2 manganese 2 plus in solution, plus 4 chlorine minus in solution. Plus 5 chlorine 2 with 0 charge gas. And plus water doesn't decompose, 8H2O as a liquid. Then we could reduce the potassium, we could reduce the chlorine. Notice the chlorine here, but then here we would be left with 10 transmissions of chlorine instead of 16. And our equation would finally be left with 2 manganese O minus plus 16H plus plus 10 chlorine minus. So the right hand side would be 2 manganese 2 plus plus 5 chlorine 2 as a gas, so plus 8 water. This is the equation that can be written down at the end of this equalization procedure. If one wishes to comment further on the ionic nature of this chemical reaction, but as you can see, it is quite a complicated procedure, as well as the equation by the electron balance method and writing such equations. But we will definitely practice in it and learn to make examples and more complex also by the method of electron balance necessarily. But that's all for today. Goodbye.